if we make a connection back that what is the main function of a diode? Main function of a diode is a one-way switch. It allows the current in one direction and it partially blocks the current in opposite direction. So our idea was to use diode as a one-way switch. It allows the current in one direction only. This is the sketch of the diode. And we discussed this idea. Now, this was the sketch of a diode. This is the characteristic sketch for a silicon diode. Look at this. Reverse bias is the left-hand side and forward bias is the right-hand side. Reverse bias means the current is being. Now you have to copy this sketch. Hello, can you hear me?
Yeah.
Okay. So you have to copy down this sketch. On the left-hand side, the line is very close to x-axis, which means that the line is not the line. The line is very close to x-axis, which means it is nearly zero.
Done.
Electric current is the movement or flow of electric charge carriers. Electric current in a wire, where the charge carriers are electrons, is a measure of the quantity of charge passing any point of the wire per unit of time. There are two types of electric current. An electric charge that always flows in one direction is called direct current. Direct current is what flows in a flashlight or any other battery circuit. Direct current is also commonly used to power heavy-duty electric motors. Alternating current is the type of current supplied to homes and other buildings. It is a flow of electric charge that periodically reverses. Alternating current came into use because it can be transmitted more efficiently over long distances, although long-distance transmission of direct current is now economic and commonly practiced. Alternating current starts at zero and increases in magnitude to a maximum, then decreases to zero, reverses, reaches a maximum in the opposite direction, returns again to the zero, and repeats this cycle indefinitely. The number of repetitions of this back and forth cycle occurring per second is called the frequency. Low frequencies of 50 to 60 cycles per second, called hertz, are used for domestic and commercial power. High frequencies, measured in megahertz, are used for television, radar, and microwave communication, to name a few.
This is a general view of this title, diodes. Diodes are diodes are important components. LED is an extra topic just for knowledge. We use LED in our homes in different devices like the small little lamps which are on electronic devices. They work in the same way. They can stop the current and they can allow the current. The difference, they can generate actually a type of light. they are very stable components, and they can generate light like different colors. Nowadays, even the road indicators, the traffic indicators are LED. Now, look at some important symbols. I will inshallah share them, and I will also inshallah share a topical past paper book as I did for maths. So the plan would be the same for any subject in O level, A level. The plan is always the same. That do some quick revision, make some notes. Digital notes is a better choice. Huh? Some notes, just like here in this chapter, circuits you should make yourself in writing, symbols, everything. This is good. Then what you do that you have to do some theory, and then you should do a lot of past paper, at least 10 years to 15 years. Doing past paper itself is a type of theory builder. So these are number of circuit symbols. Some of them you will study in O level, some of them you will study in A level. So this is like a combined collection of important symbols like thermistor, LDR, indicator lamps, and capacitor, rectifying diode, light emitting diode, magnetizing coil, fuse, electric heater, etc. Now, electric circuit, as our previous discussion, in every electrical circuit, there is a live wire, and there is a live wire, and there is a neutral wire. So whenever a circuit is formed, it has always two main components. Even when you take...
To enable charge to flow more easily, the cables that connect a battery to a receiver are made of wire, which is a good conductor. Usually, this is copper. In practice, we usually use wires that are surrounded by a layer of insulation. Often, plastic is used for this purpose. The plastic material protects the wires from shorting due to contact with each other or with other objects. To use a cable, we first need to cut it to an appropriate length and then remove the insulation from its ends. To enable charge to flow more easily,
this is a simple concept of electrical circuits and the main circuit components. This is called a resistor. What is the purpose of a resistor? Resistor is a little component which actually blocks or control the current, like speed breaker on a road, like like the traffic people on the road, they control the traffic. We have switches. This is the main switch. We have cell. Cell is a portable source for DC. This is the symbol for a cell, and normally cells have a limited output. When you combine a number of cells, you get a battery, and then these are the symbols for battery where you are combining number of cells. Now, normally when we make a battery, we combine the cells. There are two main purposes of making a battery. We get more voltage and we get more current. Batteries are portable supplies. Then we have connecting wires. They have length, color, thickness, etc. Now, this is a typical electrical circuit. An electrical circuit contains a voltage source. We have a switch. We have a resistor. And when we close the switch, current flows through the circuit. What's the theory? What's the convention? Current always is shown from plus to minus. Current is always shown from plus to minus. Look at this. Current is always shown from plus to minus. This is the direction of electron. Achha, current always is shown from plus to minus, but electrons are always shown from minus to plus, which means it is the opposite of it. Calculation based upon Ohm's law. So this is a very famous calculation part. Have you people done questions on that in school? V is equal to IR?
Yeah.
Good. So in this calculation formula, we have circuits like this, and these calculations are simple. That like other calculation, maybe some values are unknown, voltage, current, and resistance. Resistance is actually a substance to control, to stop or slow down the electrons. So we use, for example, here V is equal to IR. So I is equal to V upon R. So put the date of today and give the heading calculations based upon Ohm's law.
Done.
Now, this diagram will help us to make a practice of the circuit also, and calculation is very simple. So I don't think so we need any discussion on that, but we should make at least one circuit for revision. So you people did electricity this year, I mean the final grade or previous grade?
We did it in year 10.
Oh, right. Okay, that's good. So that will be a type of revision. Okay, now you have to copy this.
I got the answer.
Okay. So now this is a basic calculation. And now we move forward to our next concept, that in electric circuits, we always have the power sources like AC and DC. Now we talk about circuits. Circuits is very important. And when you follow a single direction of current, it is called a DC. DC circuit is normally run by a cell or a battery which has a permanent polarity. There are different types of circuits. Now we have to give the heading. So give the heading combination of resistors. Combination of resistors. Now you have to make a concept that resistors are physical entities. Now look at this is a circuit board. You might have heard about it, the motherboard or green board. This is an electrical circuit board. Now look at these. These are called resistors. These are called resistors. They are available in the market in certain numbers and certain value. Just like when you go and you want to buy some tiles for the floor, tiles are available in some particular sizes. Now, obviously, you can't buy a big tile. You have to buy the available one. Similarly, resistors are available in some fixed numbers. You have to buy number of resistors and you have to combine them to get the target value. Now, these are the resistors which are available on a number of resistors on a board. So when you make a circuit, you use the Ohm's law and you calculate the value of the resistance. Suppose your answer is coming 2.5. So you want to know, you go to the market and you want to have 2.5 ohm. But the shopkeeper can tell you that 2.5 is not available. We have some fixed sizes. So you take them and you combine them and get the required resistance. This is the idea. So types of electrical circuit. These are the combination: series circuit, parallel circuit, and combined circuits. Resistors are combined to reach a target value. So after giving the heading, you have to copy this list. Let me know once you have copied the list.
Done.
Now, if we are starting with series, what is a series circuit? A series circuit is an idea that a number of resistors are connected back to back. There are three resistors. You can see now they are in. Normally, our course starts with two resistors. The two is their common number for series, for parallel. But for understanding, you can connect a number of resistors in series. The idea is that you connect the resistors back to back. You connect the resistors back to back. The plan is simple. The plan is simple that resistors are connected the resistors are connected back to back in a line. So when you switch on the circuit, current passes through the resistor. Now there is only one way for the current. When there is only one way for the flow of current, all the current will flow through each resistor. So every resistor gets the same current. So current at every point in a series circuit is the same. But the voltage across the, but the voltage changes. Look here, that suppose I have a circuit of 6 volt. It is getting 3 volt. It is getting 3 volt. So in series, voltage is divided. But if I am sending 1 ampere, it will pass through, it will pass through all the components. So what's the theory? In series, current is the same. In series, current is the same, but voltage is divided and conserved. Voltage is divided and conserved because every device will get a separate voltage. For example, this is 10 volt. Maybe it pick up 6 volt, maybe it pick up 3 volt, maybe it pick up 1 volt. together, they have to be again equal to 10 volt. But if I'm sending here 3 ampere, it will pass 3 ampere, it will get 3 ampere, it will also get 3 ampere. This is the theme of the series circuit. So in series, voltage is divided and conserved, while current is the same for every resistor. Now you have to give the heading series circuit. You have to give the heading series circuit. And after giving the heading, you have to copy down this diagram. You have to copy this diagram. I'm just coming in a minute. Copy this diagram. Okay, have you copied it?
Yeah.
So what is the theory? You have to memorize that in series, voltage is divided and current is same and voltage is divided and conserved. So this is a combined theory. So after copying the diagram, you have to write under it that in series, voltage is divided and conserved. Voltage is divided and conserved while current is the same.
Done.
Okay. Now we have discussed this. In a series circuit, you can connect a number of resistors. Now this is the formula for the combined resistance in a series circuit. In a series circuit, the combined resistance is R is equal to R1 plus R2 plus R3. This is the combined resistance. R is equal to R1 plus R2 plus R3. This is the formula used to find the combined resistance. What is combined or effective resistance? So when a number of resistors are connected in series, we actually add them. So 2 ohm and 4 ohm are connected. So we join them and we get the combined resistance as 6 ohm. This is the concept of effective resistance. You have to copy this formula. Okay, have you copied it?
Yeah.
Now this is the concept of effective resistance. Now in series, effective resistance increases. So when you connect the resistors in series, what you will get when you connect the resistors in series, you will get a higher resistance. So in series, resistance increases. What's the benefit of that? Suppose you want to get 6 ohm in total, but in market 2 ohm and 4 ohm were available. So you join them in series to get 6 ohm. This is the concept of the effective resistance. So in series, effective resistance increases. Normally, series circuits in our homes are less common, We use them when we want to run similar devices and we want to control them by a single switch. Sometimes we have these type of circuits also, like our two lamps, and we connect them in series so they can off and on together, these type of lights. Our main supply in our house is also a series circuit. And when we switch it off, one switch, we switch it off and the whole circuit is gone. This is a power button in our all main common devices. This is again a series circuit. Now, resistance increases in a series circuit, so current decreases. In a series circuit, as resistance increases, look at this, there is only one resistor, which is 2 ohm. So when I calculate the current, I'm getting 6 ampere. So when I use two resistors in series, my current will decrease to 2 ampere. So in series, current decreases, resistance increases. Normally in our MCQ or normally in short questions, we use the concept of ratio. What is the concept of ratio in maths? You have already know that in maths, there is a concept of ratio, for example, 2:3. So one component will be 2/5 and other component will be 3/5. So we apply this approach here. There are two resistors, 2 and 4 ohm. Ratio of resistor is 2:4, which is 1:2. So the total voltage is 12 volt. So we apply the logic ratio upon sum of ratio into total. When you apply this, one of the resistor, which is the 2 ohm resistor, will get 4 volt, and the right side one is the 4 volt. This can also be done by Ohm's law. You first combine the resistors. The effective resistance is 6 ohm and the final output is 2 ampere. This is by using Ohm's law, and there are two approaches in solving this type of questions. Either you apply Ohm's law or you apply resistors in series as a ratio. Ratio method means that in series you can apply direct ratio. You can also apply Ohm's law. Now, there are two methods to deal with circuits. One is called ratio method and second is called Ohm's law. What's the benefit of series? There is an advantage and there are some disadvantage. What's the benefit and what's the disadvantage? In series, if one lamp goes off, like these are the number of lamps, and if one lamp goes off, the whole circuit is gone and you have to now search for the problem. This happens a lot when you are using electronic gadgets and other things. You find them sometimes they stop. Now, no idea what happened. This is a problem with series. If one component fails, the whole circuit is gone. In benefit side, like series has a control. One single switch can control everything. The benefit, like for example, this is a cooling fan. You can see this is a cooling fan. This is a cooling fan on computer motherboard. What's the benefit? It is in series. If this cooling fan stops due to any fault, the motherboard will also stop because we want to save the motherboard. Cooling fan is not expensive, but motherboard is very expensive. This is the benefit of series. Similarly, our household circuits are connected in series. Switches, main switches, fuse, circuit breaker, they all are connected in series. This is the advantage. So this is a theory of series circuit, the advantages and disadvantages.
The series arrangement in which these electrical devices are connected is not used as often as a parallel one. This is because when bulbs are connected in this way, they are dependent on each other, so that when one of them burns out, the whole circuit is interrupted. The most common application of a series circuit can be found in Christmas tree lights. One set can comprise up to 100 light bulbs connected in series. As the elements that are connected in series all form one loop of a circuit, the same current must flow through the whole loop, so the current flowing through each of the devices connected in series will be the same. The series arrangement in which these electrical devices are connected is not used as often as a parallel one. This is because when bulbs are connected in
Now give the heading parallel combination. A parallel combination is there when a number of resistors are connected across a common pair of points. Like if you have seen extension leads in your house, which are less common, obviously there, but extension leads are there in which we connect multiple devices in a single board. This is called a parallel combination. Look, this is called a parallel combination. So what's the idea? Current travels in a straight line like the traffic on a road. If you provide multiple paths, current can divide like vehicles can divide on a road. Again, they can merge back. This is parallel combination. So the sum of current entering a junction in a parallel circuit is equal to the sum of the currents that leave the junction. This junction concept is very important in our course. So after giving the heading, you have to copy this concept. Let me know once you have copied it.
Done.
Look at this diagram. Current entering a junction is equal to the current leaving the junction. Copy this.
Done.
Okay. Look at this. This is a parallel combination. I have opened the switch. Now current is going on. Look, now the current is dividing. This is the main feature of a parallel circuit. Okay, now this is called parallel circuit. In parallel, current is divided and conserved. This is called the junction rule, which we have just discussed. So now you have to copy this. In parallel, current is divided, so current is conserved as a junction in a circuit. Now, our next concept, in parallel, voltage is the same. You have connected one resistor, it is getting 6 volt. When you have connected two resistors, it is also getting 6 volt. In parallel, voltage is not divided, current is divided. So in parallel, voltage is divided and conserved. In parallel, current is divided and conserved while voltage is the same. Current divides, but the voltage is same. So you have to complete the sentence. In parallel, current divides, but the voltage is the same. Now you have to copy this concept. Have you copied it?
Yeah.
Now look at this. Multiple resistors in parallel and the current is divided and conserved. Voltage, current is divided and conserved, but voltage is the same across each resistor. So now you have to copy this circuit diagram also.
Done.
This is called a parallel circuit. In parallel, resistors are like this. This is a parallel combination. You connect the resistors in 1 upon R. It means actually in parallel, effective resistance decreases. In parallel, effective resistance decreases. So 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the formula for effective resistance in parallel. You have to copy this.
Done.
In parallel, effective resistance decreases. In parallel, effective resistance in parallel, this is a parallel circuit. So look at, there are two resistors in parallel, 3 ohm, 3 ohm with a switch and a battery. So when you join them in parallel, the resistance is 1.5. So what is the theme concept? In parallel, the effective resistance decreases. In parallel, the effective resistance decreases. This is the theme of the concept, that in parallel, you can join resistance, and there is a formula for two resistors in parallel. And you can write this formula in this form. This is, you can remember it as product upon sum. Now you have to copy this also.
Done.
Look at this formula. Now, calculate it. We don't need to copy it, just calculate the value.
It's 1.5.
I'm getting 1.5. You're getting 1.5, right?
Yeah.
Good. In parallel, overall resistance decreases, effective resistance decreases, so less overheating. In parallel, the circuits are less overheated because in parallel, effective resistance decreases. In parallel, the effective resistance decreases. So now you have to memory this. This is a one resistor in parallel, which is getting 6 ampere. When there are two resistors in parallel, now the current has increased to 12 ampere. Our normal household circuits are in parallel. Why we prefer parallel circuits? Because we can have separate switches, we can have less resistance, we can have same voltage, we have load management. I mean, we can switch off some devices and switch, we can operate. In parallel, if one component fail, like this is a parallel circuit, if one component fail, the whole circuit does not stop. And even the current in the system doesn't have any change. Like these are two 5-ohm filament lamps. If we take out one lamp, the whole circuit doesn't go off. The circuit continue to work as usual if one of the lamp is switched off. This is the benefit of parallel. In parallel, multiple switches are possible, so we can divide the load in our homes. That is why parallel circuit is the most common circuit. This is a combination circuit. In parallel, voltage is constant, so current and resistance are inversely proportional. This is a ratio method as usual discussed. There are two resistors, 3 ohm and 6 ohm. The ratio is 1:2. When you divide the ratio, when you divide the current, you get 2 ampere and 4 ampere. The tricky part is that low resistance will get more current. So 2 ampere will be through 6 ohm, and 4 ampere should be from the low resistance one. So this is the idea of a parallel circuit.
Sometimes, in order to supply current to 2 bulbs, it is more economical to use one battery instead of 2. In order to achieve this, the wires to the bulbs need to be connected across the ends of the same battery. When the wires are long, we can make some savings by using just one of the wires as a common conductor along part of the length. At the place where the conductors separate, a junction will be formed. If we provide each of the 2 bulbs with a switch, we can see that when the bulbs are connected in this way, they can be switched on and off separately. Both bulbs operate independently of each other. This method of connecting electrical devices is called a parallel circuit. The parts of the circuit which are connected parallel to one another are called circuit branches. When electrical devices are connected in parallel, the voltage across them is identical. The voltage across a bulb can be measured directly at the ends where the bulb is connected and, as we can see here, also across the ends of the circuit branch which contains the bulb. In both cases, it is the voltage between the junctions in the circuit which is being measured. So it is not surprising that the measurement of the voltage across the 2 bulbs provides the same reading. Sometimes, in order
So we have discussed series, we have discussed parallel, which is the main topic of this chapter, and power and energy is remaining now. The power formulas, energy formulas, and obviously the main assignment for you is the maths paper, which is coming up. And after that, you can plan and you can tell me that what chapters are coming in the course of physics, and then we can go accordingly. This chapter is always important, so normally in mock 1 a lot of chapters come up, so we are stopping here, and you should try to view the exemplar document, and you also should try, as I said, if you can get the exemplar once you go to school next time, you should try to get the exemplar for 2024 paper. I don't have it. So it will be very helpful for you because you have solved these papers. So you put your solved paper on one side and open the exemplar and compare your quality of answers. You will get some good points from the examiner point of view. Okay. So we are stopping here and we will inshallah continue in our next class. Allah Hafiz.
Allah Hafiz.